So guys, as usual, I'm called Engineer Janvier. So today we are going to talk about the architectures of Internet of Things. So we are going to talk about cloud-based IoT architecture, challenges of cloud-based IoT architecture, edge-based and fog-based architectures, technology enabling fog computing technologies. Okay. So when I say the cloud computing, for me, I understand a type of computing that utilize a network of remote servers that hosted on the internet, and then that can be accessed online. So this is called cloud computing. In some system architectures, data processing is done in a large centralized fashion by the cloud computers. So this architecture is based on the location where the data processing is taking place. So the data processing can take place at the edge of the network, within the edge devices, into remote cloud computers, or even decentralized or geographically distributed data centers. So now the cloud computing is a practice of using a network of remote servers hosted on the internet to store, manage, and process data other than a local server or personal computer. So it can define also a term for anything that involves delivering hosted services over the internet, which means the purpose of cloud computing is to provide the end users the services via internet connectivity. If there is no internet, no access, no service. So cloud computing provides different services. These services include so-called software as a service, platform as a service, infrastructure as a service. So each package of services being provided is going to be explained in the next chapter, not now. So we have many challenges in existing cloud computing. First one, the location is centralized. It is not graphically centralized, which means everyone has to access the cloud computing, which is located somewhere. So it results in high latency. Latency, it means delay. Now, because many customers that are benefiting from the cloud computing services, they have to pass through the internet. So we are having the limited internet bandwidth, but the internet users are continuing to increase every day. So there is now, if you need the real-time response, sometimes there will be some of the delay in communication, which is based on the amount of the data that are going to take to be transmitted between the host and the customer, or even based on the number of internet users. Some of the users are not going to be served at the same time. Some of users are going to be served while the others are waiting to be connected. So it results in huge high latency. Second one, based on the tremendous growth of IoT technologies, we expect a tremendous growth of different IoT devices that needs the internet connection. So again, if we try to allow every device to have internet connection and to communicate via internet connectivity. We are going to have an issue of the internet bandwidth. This is the same like you want to go to Nyabugogo town, maybe you are going to use the same road, but we are around 500 people, and the road is around 6 meters width. So now it is not possible for all of us to go at the same time into the same road. Maybe we're going to take some team that are going to go first, and the other ones they are going to follow because we have a limited space of road we have to pass it through. So this is the same for the IoT scenario. Every day we are having new IoT devices that are being discovered, and they have need to communicate via the internet. We are having the issue of resources concerning devices. Here, this issue, it is that from the devices which doesn't have the enough energy to communicate via the cloud. You have to know that most of the energy or power is being consumed via wireless communication system. So now imagine you have installed a sensor node that has been deployed into the field, then it has to run on battery. So if every data collected for each second is pushed on the cloud, so the power that was reserved for these activities is going to be ended, or it's going to be consumed in a few amounts of time. And the next one, we have the issue of the internet. When the internet is not stable, we are going to face an issue like some of the packets, some of the messages are not going to reach the cloud, which means you're going to lose information. We are going to have the other issue of security and the personal privacy. Remember, if you deploy an IoT system and the data are going to be accessed and analyzed via the cloud or application layer, there you have to remember also the internet that we are relying on is subjected to hackers. So these hackers tries every day to intercept the communication between two individuals. So these hackers, they can steal information, they can change the information, they can even connect their neurons for trying to provide the false reports. There's an issue of personal privacy. I told you in the last session is that it is not a good practice that to send the personal data, health data on the centralized cloud. We are having a big data from different sources which needs a real-time analytics. So having or relying on a cloud computing system, it will not be feasible. So we need to come up with an advanced computing paradigm that would elevate the capacity and the latency constraint in the existing cloud computing. So first solution of cloud computing, we have edge computing. So here I can define edge computing as the process of bringing some of the cloud computing services happening at the edge of the network. So here we are going to allow each edge device to have data storage capability and data processing capabilities. So edge computing is a computing model that extends the cloud services to the edge devices. It refers to the enabling technology which allow the computation and storage to be performed on the edge devices. These edge nodes can be composed of many sensors. So microcontroller, if let me say you have program the embedded system, then you want data to be pushed on the cloud, and then you have to control your device remotely. So now the edge device we are talking about can be your smartphone, it can be your smart sensors, it can be a vehicle, it can be like fridge, any device with sensing capability, computing capability, and the communication capability. So now the edge computing solves the low power consumption and the larger connection because instead of sending everything on the cloud, the data are going to be consumed nearby where the data produced, which will result in low latency and high reliability problem of our Internet of Things. So now why do we need edge computing? With the growing quantity of data generated at the edge, speed of data transportation is becoming the bottleneck for the cloud. So every day we are connecting new IoT devices. These IoT devices needed to communicate via the internet connectivity, needs to be controlled via the internet connectivity. Imagine if all of us will have the smart home. So, if you are, what does that mean by smart home? It means now everything in your house can be controlled on the internet. It can be monitored on the internet. So now we are going to have billions or trillions of new internet devices, but the channel, the internet bandwidth allocated for those communication is still the same. There is no change. So we are going to face an issue of high latency in communication. That is why we need the data processing, data storage at the edge of the network so that you can send only a few amount of the data to the cloud that needs maybe to be analyzed later for improving the performance of the system. All kind of electrical devices will become part of IoT. So imagine if every electrical devices all over the world has the internet connection. Then it can be accessed on the internet, monitored on the internet. It's a good, but we have an issue of the internet bandwidth. Imagine if we do have like the smart health or smart traffic light or smart bus. So for a smart traffic light, for taking the activity, for taking any decision, it has to rely on the data from the cloud. Now, imagine we have a scenario where we have an unstable internet connection. Then the traffic light, it captures the data, the traffic in its surrounding environment, to push those data into the cloud to be analyzed. Then it waits the response or feedback from the cloud. So if the internet is not stable, there we might cause the accident because there is no way to manage the traffic. Imagine when you have a smart hospital where the doctors needs to treat the patient or to make the surgery. Then by making the surgery, for a doctor to identify any next step to move, it has to rely on the feedback from the crowd analytics. If the internet is not good, what's gonna happen? The patient can die. If you have the response are not the real-time response, again, the patient can die, can lose his life. This is very crucial. Some application can still benefiting from the cloud computing, but by this journey of IoT development, some application needs the real-time feedback, needs the real-time answers. So there we need to implement the edge computing. The other issue, who can be confident or happy if we are sending your personal information regarding to your health status on the public servers so that everyone can have access on it? If you are suffering from the HIV, everyone can know it. If you are suffering from COVID-19, everyone can access on this information. If you are suffering from welcome now. So actually, the privacy must be of the priority before designing an IoT system. You have to consider the privacy, the security, and even the communication latency. Your goal must be how could we minimize the amount of latency in a communication system. So computing needs to be performed closer to the sources of data to improve the services that is being delivered. Of course, the edge computing can still solve this issue of cloud computing. It's okay. But also it provides the other challenges or problems that we have to solve that are of our interest. So, first one, when I'm talking about the edge device it can be your phone. Edge device it can be a microcontroller. Edge device it can be a Raspberry. But what amount of the storage that those devices have? Imagine now if you want to install like a security camera system that has to take the videos and then try to identify what is in the video, who is in the video. So, does it your Arduino Uno or your Raspberry Pi or your Node MCU has the capability to store the video that has been captured during of week? The answer is not. Does it your Arduino has the capability to run the advanced algorithm such as deep learning, such as convolutional networks for analyzing the image and come up with the insight which would help to take further decisions? The quick answer is no. So still, we are solving the issue, but we are coming up with the new issues that needs the other or further solutions. Does it your edge devices have the enough computing power to solve all of those issues? Again, the answer is not. And not known if these nodes can perform the computation in addition to their existing workloads. This means these edge nodes still have the other duty, have the other functions that they're performing. Then, on top of that, if we try to add this function of computation, we are not sure if we are not overloading these devices. So for solving the problems of edge computing, now we come up with so-called fog computing. So the edge computing architecture, it has on the bottom of the edge devices that include the sensors and the embedded system. Here, this bottom layer, the data are being produced, then are being analyzed and consumed at this layer. Only few amount of data that needs later analytics could be pushed to the cloud. But we are not sure if these edge devices have the capability to analyze the huge amount of data with powerful algorithm, or they have the enough data storage. Then you come up with fog computing. So a fog computing is a geographically distributed computing architecture with heterogeneity devices at the edge of the network are ubiquitously connected to collaboratively provide elastic computation, communication, and storage services. So now we try to bring some of the cloud computing services to be performed at specific geographical locations where this computation power is being provided by the collaboration between networking devices. So we are going to have now a huge amount of data storage comparing with the single edge device. We are going to have a huge amount of computing power comparing with the edge devices and so on. Fog computing can be seen as an extension of cloud services to the edge of the network, which makes computation, communication, control, and storage closer to the end users by pooling the local resources. So, now, everyone can ask himself, if we have the edge computing or fog computing, or yes, do we still need a cloud computing? The quick answer is yes. Fog computing is not there to remove the cloud computing. Even if we are having the problems of cloud computing, but don't forget that cloud computing has other benefits than fog computing and edge computing. First benefit of edge computing, it can allow the devices to be monitored online. It can allow the data to be accessed online. Second one, it has the huge power computation capabilities. It has, again, a huge processing capabilities, even a huge amount of data storage. So the cloud computing and the fog computing, edge computing are going to work together. The services that can be the cloud computing services that can be accommodated at the edge of the network, they can now be provided by the fog computing or edge computing. Then only services that needs the cloud computing will be reserved for the cloud services. So fog computing adds an extra rich layer between edge device and the cloud layer, which means now for the fog computing we have 3 layers. First one we have edge nodes. Here the edge nodes contains the personal computer, vehicle, traffic, cameras, smartphone. Then we have the fog layers that may contain like the gateway and so on. Then we have lastly the cloud layer. So now for allowing or accommodating all of the IoT devices in the IoT ecosystem, we should consider fog nodes, should consider edge nodes, and we shall give them the computing and the processing capabilities so that we can maximize the data processing at the edge of the network. So fog nodes can connect with the end devices and users mainly by using the wireless communication modes such as 4G, Bluetooth, or Wi-Fi to independently provide the computation, and the storage services. Fog nodes can also be connected with the cloud by internet in order to make the full use of the rich computing and storage resources of the cloud. So we can't eliminate permanently the cloud services like the computation and the storage. So now the architecture of fog computing contains 6 layers. The first one is the physical layer. The physical layer, it includes sensors, embedded devices, actuators, and are there for collecting information from the environment, for detecting any change from the environment. Then the next is the monitoring layer, which now does monitor the power within the edge devices. Next layer is the pre-processing layer, which can do data processing from the sensors so that the real-time feedback could be provided in due time. It can provide data storage at a storage layer, but this storage is not a permanent, it's a temporary storage. It can provide a security by encrypting the data from the sensors before pushing them to the cloud. Then after we have the transport layer, which can accommodate the gateway and their network for pushing the data from devices to the cloud. So, fog computing has different characteristics. First one, we have low latency or real-time interactions. Because most of the jobs are being performed at the edge of the network, there is no issue of high latency because we are not interacting with the cloud every time. So the response can be provided automatically. So we save the internet bandwidth that we would use while pushing the data on the cloud. We can support now the mobility like the smart bus, like the smart vehicle traffic light, they can benefit from the fog computing. It can allow geographical distribution of data analytics. It can accommodate different kind of electronic devices from the different manufacturers and allows them to communicate via so-called interoperability. It can allow us to ensure data security and privacy before sending any data on the cloud, and even minimize the level of power consumption. So we do have the similarities between edge computing and the fog computing. So according to the architecture, now we can say the edge computing is decentralized, distributed into different edge devices, and even for fog computing, the computation is decentralized into the networking device at the edge of the network. Proximity to the end devices. Here the computation is located within the end devices, where for the for the fog computing, this computation is near or closer to the edge devices. Communication latence. The communication latence for edge computing is low, and even for fog computing, this communication latence is low. Bandwidth cost. All of them, they minimize the amount of data to be transmitted on the cloud, which makes the bandwidth cost to be low. Edge computing is more limited resources. We have seen the edge computing, it has hunger of the energy, it has hunger of storage, and so on. And for the fog computing is limited comparing with the cloud computing, but is improved comparing with the edge computing. Computation and storage capabilities. For the edge computing is more limited. We don't have enough computing power. For computing, we have somehow increased the performance in the computation, but still limited comparing with the cloud computing. Edge computing and fog computing, all of them, they support mobility. It can accommodate the mobility of electronic of outer devices like the smart bus, smart vehicle, and so on. Scalability. So it is very easy to scalable the edge architecture and even for computing. It is very easy to remove or add a sensor node on edge computing. It is very easy for computing to add a device. You can do virtualization for both edge computing and fog computing. So now, what is the difference between edge computing and fog computing? First, let's look on the edge computing and the fog computing in terms of 3 points. First one is location of the data processing storage. Second one is the data handling. Last one is the focus. So the computation in edge computing is located at the network edge, specifically within the edge devices. However, data processing in fog computing is located near the edge and within core networking of the edge devices. Edge computing cannot support multiple IoT applications. It only handle a single application at a time. But for computing, it can support multiple IoT applications. Edge computing, it focuses on things level, while for computing on infrastructure level. Now, what's the application of fog computing and edge computing? This can be applied into the healthcare. I told you an example when we have a doctor who wants to make the surgery and who can rely on feedback from the crowd so that he can know which next movement to take while making surgery. Relying on the cloud computing is not a good practice. Actually, we can still looking for the real-time response or answers from the fog and the edge computing. When we are having the smart vehicle and smart traffic light, all of this kind of the system cannot be supported as well with the cloud computing because we need the real-time feedback within due time without a high latency and so on. Guys, this makes the end of the session. Do you have any question, any suggestion or idea on what I have presented?
I have a question.
Yes, please go ahead.
I didn't understand how the difference between the fog and the edge. Can you help us to give us the the good difference when the people ask you the difference? How you can express in a few words in summary?
So actually, this architecture that we are talking about, it depends on the location where the data processing and the storage are taking place. For the computing and edge computing, this data processing analytics is being performed at the edge of the network, all of them. Then, what is the difference now between the edge computing and the fog computing? In edge computing, the data processing is taking place within the edge devices where the data has been produced nearby the sensors that has produced the data. Then, for fog computing, we try to allow the devices to network together to create elastic computation. Instead of allowing the data processing to be hosted on the single edge device, now we're going to allow different IoT devices to collaborate, to work together to provide elastic storage and the power computation capabilities. That is only the difference between them. Now, at the first layer, we have edge computing, which is happening within the edge devices, like Raspberry, like your microcontroller, like within a smartphone, and so on. Then the fog computing is the layer between the cloud computing and the edge computing. And most of the time, this fog computing is happening at the networking device, like at the level of the gateway and its network. Am I answering your question now?
Yeah, I have tried. Yeah.
Question again.
Yes, please.
Like,
Hello?
Yes, please go ahead.
Uh, you were explaining about the age. That we have seen that the age of computing is when the data now being processed at the age of the end devices.
Yes.
So about the fog, I'm not getting about the fog. When we say elastic computation, what is it?
he is asking about what is for computing.
So, the fog computing is the process of bringing some of the cloud services to be performed at the edge of the network, specifically in distributed geographical areas. I'm saying instead of allowing the data to be processed at the cloud computers, we are going to allow this data from the sensors to be analyzed at the edge of the network. And this computation is being provided by a collaboration between edge devices, which networking together to provide elastic data computation capabilities and storage capabilities. For edge computing, only the single device can do data processing and storage. But for the fog computing, it is being performed at the level of the gateway, where we don't have a single device which is contributing, but we have networking devices which are working together for providing the data analytics capabilities.
Okay. Uh, Meaning that the data to be processed and stored on fog computing is done in the group of code of end devices
Yes, yes,
instead
yes.
of single.
You are right. You are right.